Hi guys, this is our last YouTube video for the school year. And guess what? We get to do transformations. Of course we can't end Algebra 2 without doing transformations one more time. So today we'll go ahead and go through section 7.7. We will transform exponential functions and then we'll transform logarithmic functions. One thing that hopefully makes you feel a little bit better is knowing that the rules and formulas for transformations, once again, you'll notice that they are the same. This is probably the 8th or 9th time that we have looked at transformations during Algebra 2. And so I know most of you, if not all of you, have a lot of these formulas already memorized, okay? But just for review's sake, let's go ahead and look at them again. If you have a vertical translation, now think about vertical lines. They run up or down. A translation is another name for a slide. So a vertical translation means that you're taking the figure and sliding it up or down. The rule states that you rewrite the function the way that it is and add or subtract to the end. If you add, you're moving up. If you subtract, you're moving down. Now, horizontal translation. Horizontal lines run side to side or left and right. Translation is a slide. So if you have a horizontal translation, that means that you're taking the graph and you are sliding it either to the left or the right. Notice the change only occurs 2x. So in exponential functions, you will be adding or subtracting not at the end of the problem, but within the exponent, because that's where the x is. So if you add or subtract and it remains in the exponent, it's horizontal. Now in the formula, it's x minus h. So if you go to the right, you're putting a positive value in there, it remains a minus. But if you're going to the left, you're filling a negative value in, minus a negative changes to a plus. So it's opposite of what you would think by looking at it. If it stays a minus, you're going to the right. If it changes to a plus, you're going to the left. Vertical stretches and compressions. Now that's where you want to picture that you're taking the graph, the top and the bottom, and you're either stretching it, making it taller, or compressing it and making it shorter. The formula says that you distribute what's called the scale factor into the original function. If the value is bigger than 1, like 6 in this case, it's a stretch. If the value is smaller than 1, it's a compression. Now you can do horizontal stretches and compressions as well. So picture you're grabbing the graph side to side. Stretching it makes it wider, compressing it makes it more narrow. The formula shows you, because it's in parentheses, that the change only goes to the x. And it's important to remember that if it's a horizontal stretch or compression, you have to do the reciprocal. So a stretch by a factor of 5, the reciprocal of 5 is 1 over 5. So 1 over 5 is what gets multiplied to the x. A compression by 1/3, well, the reciprocal of 1/3 is 3, so 3 gets multiplied to the x. Again, you know it's horizontal because the change stayed within the exponents. Now reflections. Reflections are shown as a negative sign. There are two different options for reflection. We reflect over the x and reflect over the y. If you are reflecting over the x, you distribute a negative into the whole thing. So you'll have that negative sign right out front. If you're reflecting across the y, it only goes to the x. So you'll notice that negative stays within the exponent. So let's go ahead and look at transformations of exponential functions. So here is the parent function. The parent function is 2 to the power of x. We have to identify what transformations occurred from 2 to the power x to get to the new function. So for part A, I still have 2 to the power of x, but what's new is minus 4. It's not within the exponent. Anytime you're adding or subtracting, it is a slide or a translation. If it's in the exponent, it's horizontal. If it's not, it's going to be vertical. So this is a vertical, and you could put slide or translation. If you have translations or slides, please tell me the direction you're going. Vertical lines run up and down. This is minus 4, so you will be going down 4. Done. The next one, I have 2 to the power of x, so they rewrote the function and then they added to the end of it. So again, it's another example of a vertical slide or translation, and you can write it whichever word you want. They mean the same thing. This time it's plus 1, so we are going up 1. The next one, again, adding or subtracting. When you add or subtract, that's that translation or slide. We are subtracting, but it stayed within the exponent. So that is a horizontal slide. I must have put in a positive 2 here because remember the formula is x minus the direction you're going. Because it remained a minus, that means you put in a positive 2, so we are going to the right 2. Okay, now the next one has 2 changes. So what I want to do is go ahead, if I look here, there is a negative just with the x. Remember, whenever you have a negative, that is going to represent a reflection. If the negative is out front, it's across the x. If it only is with the x, like it is here, it's a reflection across the y-axis. Then, not in the exponent, I have a plus 2. So if you add or subtract at the end, that's a vertical slide or translation. I'm adding 2, so I'm moving the graph up 2. Last one for exponential functions. Now this one has quite a few things, okay? One thing that I want you to get used to, because I know a lot of you are going into college algebra, and transformations will be there quite a bit. Once you take the step from Algebra 2 to college algebra, they are going to really focus on the order that you state the transformations. So as we go through these notes, I'm going to try to go in that order just to get you ready. When it comes to your test, whatever order you put them in is just fine, okay? So just to get you ready, anything that's in parentheses goes first. So it's very similar to the order of operations. So in parentheses, we are adding and subtracting, or in this case, just adding, and it's staying in the exponent, meaning it's only going to the x, so it's horizontal. Adding and subtracting is a translation or a slide. In college algebra, they're going to add another word. They call it a shift. Now, this is a plus 1. That means I filled in a negative 1 there. That means I'm going to the left 1. Now, I have 2 other things here. We have a negative up front and a 2 up front. We're going to focus on the number first. I am multiplying a number that's greater than 1 out front. So that is a vertical because it's out front of the whole thing, not just the x. 2 is bigger than 1, so it's a vertical stretch. Then I have a negative. Anytime there's a negative, that is a reflection. This time, the negative sign is out front of the whole thing, so it's a reflection across the x-axis. Now again, if this was an area where you struggled a little bit, your chapter test that you're taking on Friday to end Algebra 2 is an open book test. So please feel free. You can use these tables that have the rules. Plus there are examples. So it can show you, okay, if you have 2 to the power of x plus 3, what happened? So please make sure that you do utilize your notes. You can rewatch the videos. I know some of you were rock stars at transformations. For some, this was pretty darn hard, okay? So it is an open book, open note test. It is not bad if you use your notes. In fact, it's just going to help you and it's totally fine, okay? Next thing, so that was exponential functions. Now we're going to go ahead and look at log and natural log. Now remember, a natural log is a log with a base of e. So they are both logarithms. You can do transformations of logarithms. We can stretch them, reflect them, translate them, any of those things. So again, I provided a chart for you to look at just to kind of show you some examples of what would it look like if you were doing a vertical translation or a vertical stretch or a reflection to a logarithm. One thing that I want to point out, notice if it's horizontal, you are going to have the parentheses because in order to keep the change to only the x, it has to be set off in parentheses. Same thing with the horizontal stretch and compression. Notice it's going to be shown in parentheses to make sure that it only goes to the x. Otherwise, you guys, all these rules are the exact same thing. We use these rules to transform. We did points, then we did lines, then we did parabolas, then we did cubic functions, then we did quartic functions. In chapter 6, we did so many crazy things. Okay, so these are the same rules The things I just wanted to point out that if it's a horizontal translation or a horizontal stretch or compression, the change will be in parentheses. Let's go ahead and do some. So the parent function is the log of x. So again, getting you ready for college algebra. Multiplication goes before subtraction. So if I have a 5 being multiplied out front, that is a vertical. 5 is bigger than 1, so that's a vertical stretch. Now I'm subtracting, not in parentheses, so that's a vertical slide. Because it's -2, I am moving the shape down 2. Okay, here's another one. You multiply before you add. Again, 3 is larger than 1, so this is a vertical stretch. I'm adding at the end, not in parentheses, so this is a vertical translation or slide. Vertical lines run up or down, so it has to be up or down. If I'm adding 5, I'm going up 5. Okay, now the next one. You do parentheses before anything else. Okay, even though it's adding, anytime there's something in parentheses, that's what you want to do first. If you are adding or subtracting in parentheses, that is a horizontal slide. Because it's a plus here, that means that I must have filled in a negative value, so we are going to the left 3. Now I'm multiplying 2.5 out front. 2.5 is bigger than 1, so it's a vertical stretch. Last example that has a log. Then we're going to look at a natural log. So again, if I was focusing on the order, in parentheses I always come first. So it's adding in parentheses, so that is a horizontal slide. Horizontal lines run left and right, so it has to be either left or right. This is a plus. That means I filled a negative value in, so I actually went to the left 2. Now I have multiplying and subtraction. Multiplication comes first. It is just the order of operations, guys. If there's a 4 out front, it's vertical because it's going to the whole function. 4 is greater than 1, so it's a vertical stretch. Now I'm minusing 3 to the end. This time it's not in parentheses, so it's a vertical slide. Vertical lines run up or down, so it can only be up or down. This is -3, so I'd be going down 3. So again, same rules, but looking at it in terms of a logarithm. Now let's do a natural log. Okay, so if the parent function is the natural log of x. Now in parentheses, I have 2 things. You're multiplying by a -1 and you're adding 2. Multiplication comes first. Anytime it's a negative sign, that represents a reflection. This reflection is in parentheses. It's only going to the x. So it's a reflection across the y-axis. Now I'm adding or subtracting in parentheses. So it's a horizontal slide. Because this is a plus, that means that I filled a -2 in here. So we're going to the left 2. Okay, the next one. If there's a change in parentheses, you'd want to do that first. I'm adding or subtracting in parentheses, so that is a horizontal slide or translation. This remained a minus, so that means I filled a +4 in, so I'm going to the right 4. Then there's a negative out front. Anytime it's a negative, that indicates a reflection. If it's out front of the whole function, it's a reflection across the x-axis. Okay, here's the next one. In parentheses, adding or subtracting. So again, horizontal slide. I'm adding here. That means I filled in a -1 because minus a negative would make this a plus. So I'm going to the left 1. Now I have multiplication and subtraction. Multiplication goes first. It's a negative, so it's a reflection. It's out front, so it's a reflection across the x-axis. Then I'm minusing at the end, not in parentheses, so it's a vertical slide or translation. Vertical lines run up and down, so it either has to be up or down. It's -2, so we are taking that function and moving it down 2. So there are times where, check this out, there are 3 different things going on. Okay, the next one's just to kind of save us time, I'm just going to talk you through them. Okay, so here is the natural log of x. I'm multiplying 1/4 out front. 1/4 is smaller than 1. So it's a vertical compression. Then I'm adding to the end. I'm adding not in parentheses, so it's a vertical translation, up 3. Next one, in parentheses, I'm adding, so that's a horizontal translation. Because it's a plus sign, we're actually going to the left 1. Then there's a negative out front, so that's a reflection. Because it's out front, it's across the x. Then I'm adding or subtracting at the end of the problem, not in parentheses. So this is a vertical translation. Because it's -2, it's down 2. So we have looked at how do you do transformations for exponential functions, logarithmic functions, and natural logarithmic functions. Okay, now the last thing we're going to go ahead and do today is go backwards. They're going to give us a parent function, and they're going to tell us, well, what types of what types of transformations do they want done with this function so we can figure out what it would look like. So we have 4 to the power of x. If we are reflecting it across both the x and the y, to reflect across x, a negative goes up front. To reflect across y, a negative goes in front of x. Then if you want to move down 2, well, that's not in the exponent. That's at the end of the problem. To move down, you just -2. Okay, here is the next one. I'm going to go ahead and start off with the natural log of x. If it's compressed horizontally by a factor of 1/2. Horizontal, so I know it's going to be in parentheses. Stretches and compressions, you do the reciprocal. So the reciprocal of 1/2 is 2, so it's 2 times x. Then you move 3 to the left. Left and right is horizontal slide. If you're going to the left, it's actually shown as a plus. So all of the changes this time end up being in parentheses because you're compressing horizontally and you're moving to the left, which is a horizontal translation. Okay, this time our parent function is a log of x. If I want to translate it 3 units left, going to the left, that is a horizontal translation, so it has to be in parentheses. X left, you're putting in a negative, so minus a negative, it will be shown as a plus. Stretch vertically, vertical stretches and compressions, the factor goes up front by a factor of 2. The reason why that's a stretch is because 2 is bigger than 1. Okay, now this one, you guys, I forgot a word, sorry. This is vertically. Okay, so the natural log of x is stretched vertically by a factor of 3. That means that the 3 goes out front. Reflected across the x-axis, if you're reflecting across the x, the negative goes up front, and shifted 2 units to the left. So that's a horizontal slide. So x plus 2 is in parentheses. Last slide, you guys. This is our last slide of our last set of notes for Algebra 2. I want you to know that I'm very proud of you, the way that you've handled distance learning. I know this is not ideal. I just thank you so much for hanging in there and doing your work. And I hope more than anything, more than you can even imagine, that we are back in the classroom right away next fall and we can be together again. So last slide of the year, please know that I miss you so much. You are cared for, you are loved, and I cannot wait until we can all be back in the classroom together. And with that, let's do transformations one last time. Here we go. My parent function is 0.7 to the power of x. If I want to do a horizontal stretch by a factor of 3, horizontal stretches and compressions, you do the reciprocal. So the reciprocal of 3 is 1/3. So that 1/3 gets multiplied only to the x. So I know that it's only to the x because it stays within the exponent. Reflected across the x, the negative goes up front. translated 2 units left. Now that's horizontal again. So when I add 2, it has to stay with the exponent. Okay. I have the log of x, translated 12 units right. That is a horizontal slide. If I'm going to the right, this will remain a minus because it's x minus. The right is a positive direction, so I'm filling in a positive 12. Vertically compressed by a factor of 1/2. It's a compression because 1/2 is less than 1. Translated 25 units up, and we're done. E to the power of x is stretched vertically, vertical stretches and compressions. You have the factor out front, so it's 2 right in front of the e. Reflected across the x, the negative goes up front, e to the x, and then translated down 5, you'd have a -5 at the end. Last question, big breath. 1/2 to the power of x. If I'm going to translate that 4 units right, that is a horizontal slide. So it's going to go up just with the x, okay? So if I'm going to the right, it's x minus, I'm filling in a +4. Stretched vertically by a factor of 1.5. This is a stretch because 1.5 is bigger than 1. Reflect across the x-axis, so I put the negative there. Okay, now guys, you have no assignment for today. Today was just a refresher on transformations. You do have your last test for the year. Your last assignment is tomorrow. It is open book, open notes. One thing that I did include in your packet is a study guide, as well as I'm going to upload the solutions to the study guide on our Google Classroom. It's totally optional. If you want to review for the test, that would be a perfect way to do that. If you're not really worried about it because it's open book, open notes, you have the rest of the day to do whatever you want math free. But again, I'm very proud of you. I hope you have an amazing summer, and I'll talk to you soon. Take care, guys.